many people incorrectly computed the limit as x goes to 0 of this ratio of two polynomials here. Now, the reason why many people miscomputed this limit is because they were taking at face granted a rule we talked about and applying it in a situation where it doesn't really apply. So in class, we were discussing the fact that if I'm looking at a limit as x goes to infinity of a ratio of two polynomials, right? Then what we can do is we can ignore the slower growing terms in the numerator and denominator. In this case, that would be the 2x and the x, and focus on the relative growth rates of the higher order terms. So in this case, that would lead to the answer limit as x goes to infinity 1 over x, and that would in turn give us the answer of 0. Right? But the problem here is in this quiz question, it's actually a limit as x goes to 0 of this ratio. And we cannot apply the same sort of reasoning because actually as x goes to 0, the x squared goes to 0 faster than the 2x. If you don't believe me, try computing a few values. If I take x to be 0.1, what's x squared? Well, it's 0.01, right? 1/10 to 100th. If I took x to be 0.01, this would be 0.0001, right? So we can see that this x squared is actually the lower order term at 0, even though it's the higher order term at infinity. So to keep from making these mistakes and getting confused, what I would recommend doing when computing limits at 0 is to actually factor out the common terms from the numerator and denominator, in this case x. So that would leave us with x plus 2 in the numerator, and in the denominator, x squared plus 1. In this case now, the x's would cancel, and we would be left with a limit as x approaches 0 of x plus 2 over x squared plus 1. And now, since this is a ratio of two polynomials and 0 is in its domain, this is continuous at 0, so we can just plug in 0 for x into both the numerator and denominator, leaving us with 2 over 1, or in more everyday terms, 2.